Hey folks, this is Anatoly and you're listening to the Solana podcast. And today I have Jonathan Schemoul with me, who's the founder of the Aleph.im project. Really awesome to have you.
Thank you very much. I'm really happy to be here today.
Cool. How did you, we usually start these with a simple question. How did you get into crypto? What's your story? What's the origin story?
Well, into crypto, it's a long story. I started way back in time, a bit on Bitcoin, then I stopped because it was only money back then and that wasn't the end game for me. And then I came back into crypto in 2015, 2016, and I started doing a bit of development because I saw that I really wanted to be part of Web3, to do nice things with it. So I've started developing as an open source developer for a few projects. One of these is the Nulls project, which is Chinese blockchain layer 1. I'm not really involved with it anymore. But working with them as a community open source developer, I saw that there was some missing link somewhere, that you couldn't decentralize all the stack with just a layer 1, at least not the one that they were building back then. So that's how the Aleph.im project is born. And for me, beside that, I've been developing for a lot of companies before in the IoT space and also for big banks at some time ago. So I've been a developer for a lot of years.
That's great. I mean, that's a great background. So the thing that you're focusing on with Aleph is this idea that Web3 is just a small part of the piece, but you still need UI front ends, business logic, and things sitting
exactly.
that's on top of the blockchain. Can you how does that work?
The idea is that, okay, now you can have smart contracts on Solana. That's great. You can even do way much more than just money on smart contracts. That's great. No, you need to have a front end. So you need to have storage for that front end. And that's not all, because a smart contract, a program, doesn't have all the data that you need. So you will need some kind of indexing to get history. You will need a backend for that. Most of the DeFi applications that we see have some centralized backend behind them. They're running on AWS, sometimes on dedicated servers or stuff like that, but it's still centralized. If a government, and we just saw something about it today, wants to shut down a DeFi protocol that is organized like that, they can. With Aleph.im, what we're trying to do is decentralize the last mile, because for that last mile, most projects are using AWS. So we need to decentralize AWS. So we provide storage, as in file storage for the front-end files, database storage, because most applications are just databases, and also an equivalent to Amazon Lambda, where you start small functions that will be launched on a decentralized cloud where there is place for them, and will get you a return value. And this can be written in any language and can access the web and also RPC from blockchains. Here, Solana,
Got it.
obviously.
Super cool. So this is the storage mechanism. Does it guarantee consistency? How is it decentralized? What happens if you nuke it? Yellowstone blows up, the current set of servers from Aleph get destroyed in the volcano. Well, how do I move, switch? What state do I lose? Those are the hard distributed systems questions.
Yeah. It's a really good question. So Aleph.im is not a blockchain at all. We don't have a blockchain. There are enough already. we just accept messages from blockchains, and all the supported blockchains are accepted on the network. That means that a message that is signed by an Ethereum address is accepted on the network. A message that is signed by a Solana address is accepted on the network. All our network, hence the name .im, instant messaging. The whole system works with messages on the network. Those messages are organized by channels, just like you would go on Telegram channels and get the history of them. And the network keeps track of those messages. And when you start a new node, you get the history of messages, not directly from the other nodes. You will connect to blockchains, to specific smart contracts on blockchain, look at past events for example, on Ethereum or on Solana, you look at past events for the synchronization of the network, and you look, okay, there has been all these events. Okay, let me ask the whole network what those messages were. Then you resync, and when there are missing parts, you leave them apart, and then you get a view on the channels and on the messages.
So you write your software, your Lambda hook, as if it's reentrant, right? So you're kind of recording your progress potentially on Solana as you're processing it.
For the Lambda, it's a bit different. Here I was explaining how the network works
Got it.
for the messaging on the global state. For the state of your application, you could either get your state from a blockchain. Here, Solana, for example, all the indexing effort that we are doing is using Solana as a source of synchronization
Correct. Yeah.
for these Lambda. But then you can have multiple kind of volumes, because since it's Linux micro virtual machine, everything is a volume. So we have local storage volume that is local to the running host. And then the Lambda can then issue messages on the decentralized database of the Aleph.im project or on the storage, and then resync to the local file system and then issue messages, etc. And we are also working on another kind of file system that is distributed, where any Lambda can write in it and the other receive the changes, which is kind of tricky.
So is the database that the Aleph distributed database, is that a Byzantine fault tolerant database? Like, is it like designed like with that in mind?
Yeah, the idea is that when you send a message on the network, it gets stored by all the other nodes that are interested in your channel. And then there are synchronization nodes that go and write hashes of that data and signatures inside messages that they push on blockchains. So that when overcome, they can synchronize it and replicate all the data. So that even if one part of the network gets totally disconnected, you can have one part that gets reconnected to the other, either through the peer-to-peer network, through blockchain, through APFS. We have multiple kind of different connectivity solutions so that they can reconnect and resync.
So the Aleph database, if it's Byzantine fault tolerant, I mean, doesn't that make it a blockchain? Like, is there a token? Like, is it crypto economically like fault tolerant?
Yeah, so we have a token, but the token is living on multiple blockchain, Ethereum, Solana, and a few others, but those are the most used today. We have a token. You need a token for your data to stay there. If you don't have any more, your data gets garbage collected. But we don't have a blockchain because we go and write on over layer ones. So we are technically a layer 2 database plus computing plus storage.
But the data store, the Aleph distributed database, what is that backed by? Or is that, can I pick my own blockchain to use it as a common interface or something like that?
Well, currently it writes on Ethereum. We are working on making it write on Solana. For this, we need our indexer to be super powerful, and that's what. So we will get it writing on Solana very soon. And basically, it can write on multiple blockchains and use it as a source of proof.
Got it. That's pretty interesting. So it really doesn't have its own blockchain, and you're just using the fault tolerance of the chains you're connected to.
Exactly.
Awesome. Yeah, that's really cool. So the other challenge, I think, is like, how do you deal with like domains and the web, and like, where do you run these executed nodes? Like, how do you connect all those pieces?
It's a really good question. To connect all the pieces together, we didn't develop some really fancy stuff like proof of space and time and things like that to like verify that the data is really stored. We are using something much more low tech, which is just a quality control. We have core channel nodes, which are the controllers of the network, which need to like keep some Aleph, have stakers on such economics. And they are verifying that other core channel nodes are behaving well, and that also the resource nodes are behaving well. And then the resource nodes are really doing the work of storing data, providing computing, etc. And they are continuously controlled by the core channel nodes.
That's great. So they're like basically like a tokenized health check,
Yeah,
right? I can spin these up and they can continuously monitor whether this computation is making progress, right?
exactly.
Is that verification? Is that programmable? Can me as an app developer, can I kind of like code up my own app specific health checks, or is it or like an interface or something like that?
It's a really good question. That's what we are working on exactly right now.
I'm
Because
leaking all the
because
features. Sorry,
because
my imagination is going.
no worry. Well, it's really interesting because to like understand if an application behaves well on one host, you need to understand what the application is doing. So yes, we will give some kind of like health check, which is kind of a unit test of how the app should work. So you will be able to like provide unit tests for your app, basically.
That's really cool. What about domains, like actual DNS?
Yeah.
I'm asking all the hard questions, man.
Yeah. So these questions will be answered if I explain how we handle access to this virtual machine. Because for DNS, for just IPFS, there is already quite a few solutions. That's not an issue. But then if you want to make a domain point to one micro VM, you want your micro VM to be able to like serve your data. How we do first the load balancing, because that's the important question. For load balancing, we have two ways. One, which is a regular cloud load balancing, which could be blocked by government, could be censored, because that's what can happen when you have centralized point of control. We will run it ourselves, and a few of our partners might run some of the cloud load balancers that basically you can just point your domain to the cloud load balancer, and then the cloud load balancer will like create certificates and stuff like that. It will work. We will run one instance. Ubisoft will likely run another, unlike many other partners. Well, for Ubisoft, it's not sure. It's just some talks about it. But perhaps other partners could like run cloud load balancers that would go on point on specific micro VM host to like see where your app is running and point it to them. That might work. Now, what happens if a government says this the app shouldn't work? This domain shouldn't work. Then you have two solutions. You either put the front end inside IPFS and use some IPFS gateways, etc. And then the backend is on the VM network. Then it could not. But then what happens if your government blocks the specific DNS inside the micro VM global.aleph.sh.aleph.cloud, whatever? Then we have decentralized load balancing that comes into play. The idea of the decentralized load balancing is that your browser will connect to the IPFS network using lib peer-to-peer, JavaScript lib peer-to-peer, find PyAleph nodes running, contact them directly, then ask PyAleph node what micro VM hosts are running this software, and then you can contact them directly. So we are working on a JavaScript library that will do all this work on the client side so that you can have your front end in IPFS that will then go and find all the backend hosts that could answer your request.
That's super cool. That's those are you guys are working on some really hard problems. So I think it should be fairly easy to kind of have a basically resolver that points to like ENS, right, in the system,
Yeah,
right? That's fairly straightforward, and basically you should be able to use any kind of like name system coming on any blockchain.
yeah, clearly.
Do you think that this is something that browsers are starting to like recognize as standardizable? Like, is there like a future where you think this technology could start percolating to the UI level, where the end user can pick like a blockchain based DNS resolver that links to that starts kind of like connects all the pieces, right, from the human to this decentralized web?
I think that's something that could come. I think that those that could really help in this is the Mozilla Foundation. I think that they would be the one to talk with. We aren't in talk with them because we don't really take that step right now. We have a lot on our plate, but in the future, I'm pretty sure it's the way to go, and we will connect to like any effort in that area, and we will recognize it. I know that for IPFS, for example, IPFS, IPNS, there are some efforts on some browser extension that you can install to have it, etc.
Do you guys have how does like certificate chaining play in with this? Like what happens if I need like to have like a, you know, a cert on my service and things like that?
Certificate on your service, yeah.
Like, you know, like VeriSign or whatever.
Well, we use the one that everyone uses, which is
Let's Encrypt, the EFF one.
yep, exactly. Yeah, we're using this one, and we use the discovery with a content so that we switch to a specific content when Let's Encrypt connects, and then we serve this content, and then we get a valid certificate, and we can serve the good content.
Can you unpack that a little bit?
Yeah.
Yeah.
Well, Let's Encrypt has multiple ways to like certify that you have a certain domain. For subdomains of .aleph.sh and .aleph.cloud, it's easy. We are using wildcard certificates. For custom domains that you could make point to your content directly, what we do is that you put a key inside your DNS to say, this is the virtual machine that should be mapped to that domain. Then you do a CNAME to our cloud load balancer, and then the VM hosts, when they get a request for this one, they go and check the DNS to see what VM they should serve, and they generate a certificate using Let's Encrypt for that domain, and they start serving it.
Oh man, this would be really cool. But if we could have like an ENS where in my ENS registry, I set my Let's Encrypt domain, and then I run a local DNS server on my home machine where I run my browser,
Yeah,
and point that as the resolver. You could kind of tie these knots together
yeah, it could
and
work.
and that's really cool.
Yeah.
So, so what happens if these instances die? Where do you guys get more hardware? Like how does that process work?
Well, an instance can just stop. Then the load balancing system will find another instance to run your code. Then what happens when an instance gets a request for a code that it doesn't have for the micro VM network? I mean, it goes on the network, checks, okay, what is the database entry that is in front? It takes the database entries. Has there been any upgrades to it? Okay, I get the upgrades. I subscribe using WebSocket to the upgrades of this database entry, basically, because it's a document database entry. And then it looks, okay, so this is the rootfs that I should load. Do I have it? I have it. Cool, I use it. If not, I download it from the network. I apply that rootfs. Where is the code? Okay, what volume does it need, and it builds, and it runs it, and it gets you the answer. For a cold start with no rootfs or whatever, it can take a few seconds, but in general you use the same rootfs as others, so you can get a cold start. If you don't have the code, it's less than a second. If you already have the code of the application, it's like 150 milliseconds for a cold start.
Got it. And is the coordination to decide where to start this particular instance, does that occur over like the underlying chain, like Solana or Ethereum or whatever?
So again, that's something that we are working on. At start, it's on the cloud load balancer. So the cloud load balancer are semi-centralized for that. The idea is that each micro VM running node that starts running one will register a message, which is a database entry with a reference to say, I am running this one. And then the cloud load balancer looks at the uptimes of the available micro VMs and say, okay, this micro VM has it ready. I'm forwarding it to it. And then if there is none, then it will just route it to like a random one that has a good uptime. And then this one, the next time, can like be chosen automatically because it is already serving it. If there is a lot of requests, it will provision multiple ones.
Interesting. Got it. And you anticipate that you'll basically be able to move if the underlying chain is cheap and fast enough. You should be able to move the coordination and kind
Yeah.
of like, hey, start this instance, pull this volume. Um, this would be really cool with like Arweave backed storage volumes, because because you could almost then see the life cycle of the application as its business logic is evolving, right? Like that
Yeah.
state is very useful to developers, right? Being able to go back to a checkpoint effectively at any given time too.
Well, right now we are using our own storage engine, which is IPFS compatible. But in the future, we will allow to like choose other storage engine, and we will also develop gateways with like Arweave, Filecoin, and others.
Super cool. I used to work at Mesosphere, so I don't know if you heard of them, but like, or D2IQ now. This was like a kind of Kubernetes
Okay.
competitor, like trying to build this like decentralized operating system using Mesos as the jobs kind of queue engine. There's a lot of similar challenges there, and this is really cool that you guys are building this in a decentralized web application that's kind of hosted in the mythical, the real cloud, the
Yeah.
mythical, the mythical cloud, right?
Yeah. Well, there is a saying there is no cloud, it's just over people computers. And here it's really over people computer. So it's pretty good because then you don't trust those computers because you know it's over people computers.
How do you guys ensure the integrity of the computation itself? Like, how do I know that the virtual machine, the execution environment that's running isn't malicious?
It's a really good question. So there is multiple questions there. How can I ensure that this computation isn't returning a bad result because it knows who is on the other end? The load balancing system ensures that you don't really see who is in the other end. So you don't know who is making the request. So you don't know if it's a quality control call or if it's a real call. So it goes back to like your question of the testing of the application. There is another one there, which is the question of the secrets, because you might need secrets. If you want to like do push notification based on a smart contract event on Solana, let's say, because that's something that we are working on right now, thinking about it.
That's super cool.
You will need secrets. You will need to
Yeah.
like store a secret to like being able to go back to like this device and send this device a notification. So you either store secrets in the local storage of the instance, but then if the instance dies, you can't get it back, or you try to get shared secrets between multiple hosts. We are working on it. We don't have a total answer on that. What we are working on is using threshold cryptography so that multiple hosts defined by the developer can handle these secrets. And then you go back to a question of trust, which is problematic.
By threshold cryptography, is this like an MPC to compute, or are you guys thinking like BLS or like Schnorr aggregation?
More like you encrypt something that can be decrypted by multiple private keys.
Got it.
And then if they want to send a message, it needs to be signed by at least X of Y.
Right. Got it.
And because this micro virtual machine can also send messages on the network. And these messages on the network will be database entries that in the end might end up also on chain using oracles or whatever. Because this micro VM can read from on chain data. And the idea is that we are working so that they can also write on chain as well. So then you might need some kind of trust somewhere. So one developer could say, I trust this host, this host, this host, this host, but they need at least to do that calculation 3 times, let's say.
Yep.
But it's a bit problematic and we are still working on it. It's not finished yet, so yeah.
That's a really hard problem.
Yeah.
Really cool. Yeah, the secrets thing is really challenging. What do you guys, I guess, well, what's your vision for this? You guys are tackling on some really hard problems. You get all of them done in the next year.
I hope so.
And like, what happens then? Like, what is the vision for Aleph?
Well, here we are only speaking about a few crypto issues. We aim at bigger than just the crypto ecosystem. What we really want to do is decentralize the web. So, getting bigger, way, way, way bigger. That's the goal. We are working with a few bigger partners. We are part of the Ubisoft Entrepreneur Labs, for example. We want to have a lot of hosting partners in the game that start providing resources so that I want it to be as easy as spinning up AWS server or whatever. You would just spin up VMs on the Aleph.im network. I want it to be as easy as using Firebase, using as Amazon Lambda, etc. And we have another big project going on, which is the indexing on Solana, where we are indexing data for a few protocols. Currently Radium, we might have another ready soon. Well, I can say the name. We are working a lot on Orca, on Port Finance right now, on a lot of others actually that I can't really talk yet. But the idea is to have all this data available, have all this data feed coming up, so that you can have events based on them and also do off-chain computation and things like that. I really want DeFi to be totally resilient, because until it's totally decentralized, you can't stop DeFi. When it's totally decentralized, you can't. And if there is only the smart contracts that are decentralized, you can still stop it.
Yeah, that's definitely a fair point. I think the UX issues around building also just like push notifications and all these other things for projects are really hard to overcome if it's a decentralized project, because who's going to host those servers, right, to
Yeah.
connect to mobile and everything else? Yeah, you guys have a lot of work set out, and it's pretty exciting. What do you wish? What do you think is missing? Like, if you guys had like somebody else was building this other piece that you think is missing in the Web3, what would it be?
What is missing today in the Web3 is of use of all this. We are trying to tackle this, but we have so much on our end. So this is a big issue. Ease of use for developers, ease of use for users. Well, Phantom is already doing a great work on that end on Solana. But yeah, this, and also I think that there is some kind of breaks between the in DeFi. If you want to move money into the real world, it gets hard really fast, because there has been some kind of complication that have been put in place by regulators, by banks, by whatever. If we could just get all these parts simpler, it could be great. Like some kind of link between fintech and crypto that would work everywhere in the world, including Europe, USA, etc. It would be great. There are a lot of people working on it, but that's something that is missing as well.
Yeah, identity and like having those easy ramps is still hard. What about DNS? Just straight up resolving. Like, do you think that's tackleable from a Web3 perspective?
The issue is the way DNS is done. DNS protocol is great, but it implies centralization points, a lot of centralization points, which are problematic. Then you would need another standard than DNS. But if you have another standard than DNS, then you have the issue that the network right now is not done for it, and the browser don't understand it, etc. And operating system don't understand it. So we would need gateways for that. I think it's doable. It's definitely doable, but it's a lot of work, and you would need multiple root servers and even virtual root servers, like what you said, local DNS server that would resolve your request. It could work. If Let's Encrypt could understand it in the same way, it would work. Or we could even have something different than the root certificate that we have today, because with blockchain we already have private keys, we already have signature. So if you sign your content with your private key, then you can verify it on the other end, and you don't really need all these chains of certificates that are here today. So that could also be another solution. But it would need another way because right now we like have root certificate, children certificate, etc. And it all goes back to like central authority. The whole DNS on certificate system today goes with authority. And with blockchain, we are trying to like remove authorities.
Yep, yep. Do you guys see this as becoming developer facing, or maybe someday eventually kind of like client facing? I want these decentralized applications running for me, like kind of my own instances. Or is this always going to be here I am, Team Orca, go to this domain and as a user?
It's a good question as well. It's always the issue like between hosted components, locally run components. I'm kind of pragmatic on that. At start, I would really like to like everything runs inside my browser, everything works. That's great. In reality, you have mobile phones, you have tablets, you have computers, you have a lot of range of devices that can't be running all the time. So real peer-to-peer application can't really work that well unless you like go and say, okay, while you are waiting for me, please send it to my friend that will forward that data for me, etc. And blockchains are really helping there is that we have a centralized authority, which is the blockchain, that you can trust and that can hold data for you and can even hold it encrypted for you or store it on Aleph.im, whatever, and only you can like decrypt it. So I think that a mix between the two would be good, like self-hosted data and remotely hosted data on a decentralized cloud. A good mix of the two could be good. And the efforts by the Lib peer-to-peer team with the JavaScript Lib peer-to-peer, and there are a few others like that, helps because once you have access to a peer-to-peer network directly from your browser, you can cut middlemen, you can cut central authorities, etc. if you have a blockchain that serves as a central authority.
What kind of loads have you guys seen, like, or been able to test this out? Like, in terms of like, users requests per second, kind of WebSocket connections per second.
It depends because when it's per server, that's not that much of an issue because the micro VM supervisor just forwards like the request to the underlying software. If you don't use a local persistent volume, the supervisor can run as many instances of your program as needed. Then it can spawn up multiple ones, even inside the same supervised cluster. And then the network, if it sees that this one has issues ending the request load, it can load new ones. So I don't think that there is really a limit on the request per second for that. So it's not really the issue that we have. And then on the database part, same. If you access one API server and you give it 500,000 requests per second, it will go down because it's a server. If you target multiple API server, you are good. So that's also where the decentralized load balancing helps because if you use a cloud load balancer, obviously even this cloud can like go down. But if you contact a peer-to-peer network to know what host can answer, then you can contact multiple hosts. And all our core channel nodes, we are currently 54 of them, are also API servers that users can connect to get the data, which will be certified by a core channel node.
Cool. As a whole, how many, I guess, do you have an idea of how many users per second or humans per second have you guys served in some peak times?
We don't because we don't store metrics currently. We should. We don't have it because we didn't want to like have any kind of log or whatever on the users, but we could make it. We should add it. That's actually a good point. We will.
Yeah. Yeah. I mean, like, I think you got to be really aware of privacy and how that impacts some applications. But really interesting to see how this works. Caching is like another one of those things, like basically having a distributed cache around the world for like often queried data. And this is an issue that I think doesn't have a good solution in Web3 right now. Um, you like do all this work, set up a purely thin client, right? That's like loads from code, only talks to the chain, and then you got to go fetch assets. And if you're using centralized cache, they yeah yeah, like they can basically inject
Yeah,
whatever they
that's the
want.
main issue. And here the good part is
Yeah,
that if you
yeah.
also randomize where the request of the users go, if there is one bad actor, it will only inject bad data once in a while. You don't even know where. And once there is a quality control, it will detect it. So that can also be a solution. It's not a silver bullet either, but it can definitely help. So like for Solana, what we are doing right now for Radium, for example, is that we have an indexer that talks to multiple RPC of Solana and then get the transaction history, store it inside a level DB inside the micro VM, and then index the data. And then we can get data on the pools, latest trades, and stuff like that. And the idea is that if there is too much request on one indexer, it will start another indexer, another indexer, another indexer, etc. So that when you do a request, it will route it randomly to multiple hosts that have the same index.
How fast is that?
Not fast enough currently. It's fast enough for Radium.
Okay, okay.
It works. It works really well.
Radium gets some a ton of hits. I mean, like some of their IDOs have seen 500,000 requests per
Yeah.
second peak.
So for the Radium data, it handles it well. Like all the trades, whatever, it handles it pretty well. We don't get behind blocks in the indexing, so it works well. For Serum, it's a bit more problematic because you need to like watch their event queue all the time. I really hope they will have some kind of logs in the future. I think that they are working on it. So that would really help us to like be able to get history even when we aren't watching their event queue.
Yeah, sorry, not half a million per second, half a million total, which is quite different. But yeah, they see some really good traffic.
Yeah.
Cool. I mean, that's really cool. Like, I think really hard part of, I think in designing these systems is one is the problem is difficult, but then once you build the first version of it and you start hitting real traffic, there's a lot of parts that are fit together that that break under load. So what is your debugging like? How do you guys actually like monitor, like debug, like PagerDuty? What do you guys use as a team?
Right now, our team is still small. We are growing a lot. Right now, we are like 10 developers. A few months ago, we were only three. A year ago, I was alone. So we are growing really fast and we are putting all this into place. So right now, everyone monitors and checks what happens on like helps. There is Hugo, who is on the micro VM side, Ali, who is mostly on the indexer side, myself, who is looking at everything. But we are putting really real stuff in place right now to like have it because we are a growing startup, so it takes time to get everything in place.
Yeah, for sure. Do you envision a PagerDuty team for this? Like
Yes,
what?
I think that we will need one. Once we have more applications that are using it, we will need one. So yes, if you have advices on that, I'm really happy to get them.
I mean, this is just it's just part of life. It's not complicated. It's just work. This is I think like that like response team I think is a difficult thing to set up in a decentralized community.
Yeah.
If you guys are building like a decentralized network with providers that are supplying hardware and all this other stuff, those are the folks that we found to be really responsive and have a lot of stake in growing this. How do the economics work for all the people actually supplying the hardware
Uh, so
and bandwidth, etc.?
So again, the resource node economics aren't live yet. We are working on them. The core channel nodes economics is already there for like a year now. It's it works well. For the core channel nodes, you need to have like 200,000 Aleph to start a node, and I 500,000 Aleph staked on a node so that it can start to run. And then all the node operator get a share of a global envelope daily for all the nodes, and all the stakers get a part of the envelope for stakers. And the more nodes active, the bigger the envelope for staker is, but then for each node, they will earn a bit less if there are more nodes because it's a global envelope. So it helps stakers grow the number of nodes that are active. So that's for the core channel node. For the resource nodes, to get storage or computing on the network, there is two ways to get it. One that is already live, which is hold X amount of Aleph and get that amount of storage, hold X amount of Aleph and like have the ability to start one VM with X megabyte of RAM, X virtual CPU, etc. And then the multiplier on all that gives you the total count of micro virtual machines that can be running on your network based on your balance. The good part with that is that partner project could use a lending protocol to like borrow Aleph while depositing their own token to get service. And they would get the service for free, just paying interest in their token inside the borrowing protocol.
Got it.
So that's a way for protocols to get it, but it's quite expensive because they don't directly pay for it. So for this way of using it, the Aleph.im network is paying for them from the incentive pool, which is like right now it's 1/5 of the supply, and we are changing it in the next few months. We'll change a bit the economics. It will be nearly half of the supply that will be dedicated to pay for that. Because since you lock a part of the supply, then you can release a bit inside circulating because of this new use. So that's for the hold XLF tokens. And then there is another way that isn't developed yet that we will likely use Solana for because it's fast enough for micropayments in that area. It's like pay per action, like pay X Aleph per gigabyte per month. You as a provider, you can say, I am okay to be paid at least that much. And then users will say, I want my data to be replicated at least 4 times, and I'm okay to pay at most that much for this. And then it gets divided by those who provide service, and the payment is done as micropayments. And same for the micro VM, you pay per CPU, per hour, etc.
Got it. Got it. That's really cool. Well, this has been awesome to have you on the show. I mean, we got into like I think the really deep details of how Aleph works. So I had a blast because it really reminds me of the working on the stuff and for centralized systems. It's really cool to see this kind of built ground up for decentralized ones as well. So appreciate the work you're doing. Thank you, Jonathan.
Thank you very much for like having that call. It was really great talking with you.
Awesome. And good luck to you guys. I mean, startups are blood, sweat, and tears. So just keep working on the vision. You'll get there.
Thank you very much.
All right. Cool. Take care.